a place to add them. Let's just throw them into this object as well. But wait, we need some more values so that our second function later on so that it works as well. It's starting to get a little bit unreasonable, but that's fine. We've got coverage, the test passed. Let's just ship. And then next week, after we deploy and we find out we need to do something else with this thing, we've got the perfect place to add it. So I'll just stop right there. I don't really like the way that this code took shape, but unfortunately it's something that happens pretty often. And this is basically how development goes. We do what's easiest because of the near constant pressure to ship, because we just want to go home, because we're human. But also, because we're human, that means that we follow and we extend patterns that we already see in the code that we're changing. We're going to add another then to an already too long promise chain, or add another property to a massive object, because that's the most convenient thing to do. We always say that we read code a lot more often than we write it, and it does feel truthy, but regardless of whatever the frequency is, what do you remember about the last time that you changed code? I remember the emotions that it made me feel. What emotions would you feel if you stumbled onto that function? You might be upset and wonder why that person was so lazy. You might be trying to find a reason why it ended up that way, why you can't understand what's going on, and why you don't have much confidence in the change that you're trying to make. But the trouble is, at least when I ask those questions, I already know the answer. I know the answer because I've done it before. I've sacrificed and done what's convenient and prioritized short-term gain. Sometimes it's a good thing to do, like when we need to test market viability, and sometimes it's a bad thing to do, like when our team doesn't really understand what the word estimation truly means. Eventually, teams, they prove that their software can make money and they start to think more long-term, or they just get frustrated that change is slowing down and it's getting harder. This is my favorite time. This is when the real learning happens, because at this point, a team is hungry for improvements. If you're at this point, we should talk, because I love helping teams like this. Right about now, a light bulb goes off and you hear words like quality, changeability, readability being passed around. These teams, they lament their past decisions and they wish that they could just rewrite their software with these new noble goals, with the learning that they have, right? But the problem is, words like quality, changeability, and readability are very subjective. They change from person to person depending on their experience, their background, and whatever blog post that they read last week. So how do we look at those goals in a more objective way? How do we really know that we're making code better? One thing that helps me be more objective is to think about the concept of signals and noises. I like to amplify signals that help the team understand what's happening in the code, because everything else is just noise. Noise that's getting in the way of our understanding. That's it. This is the most important thing that you can do. Boost signals and reduce noise. There are a lot of techniques for getting it done and lots of new things to try. We'll talk about some of them. But if you only remember one slide from this talk, make it this one. Think more about signals and noise. So let's think about signals and noise as we fix the mess that we just made. Let's boost the signals that are already present in that code. So a function name, to warm us up, should be the first signal. When someone is exploring our code, it's the first signpost that they see, and it should be clear what's happening inside of the function based on its name. But does this function give that kind of confidence? So a name is extremely important, but it's just the beginning of the story. After a clear name, I think the most important thing that you can do is be clear about what type of function you're writing. A function should do one of three things. It should coordinate, it should calculate, or it should control. Choose one. Let's look at what those different types mean. So a coordinator, here's an example, is responsible for creating a pipeline of actions, for calling other well-named functions. It manages interactions, and that's it. Just like in real life, a coordinating function shouldn't be splitting time doing the work. It should be spending all of its time supporting and coordinating the other things that it's interacting with. This is a simple example of a calculator function. Ones like this are pretty easy to spot, but they're not the only type you're going to see. What about transitions between domain concepts? Here, we're extending the idea of calculation so that it's not just limited to math. We're extending it to calculate a new type of object in our system. The best way to understand the next type of controller function is to first look at a bad example. Conditionals like this, I think, are evil. They mix function types and they create a confusing situation. Now one function, and therefore one test, is responsible for choosing the correct path, keeping each path straight, and actually performing the action. And worst of all, conditionals breed, because the most convenient change to make when you have a conditional like this is to make it more complicated. This is better. This is a different example of what a controller function can look like. We've created an abstraction that allows each branch to only worry about itself. The only thing that this function is responsible for is controlling flow through the application. So those are the three types of functions. We need to choose one for that function that we just wrote. Which one is it? When we look at it like this, I have no idea. I can't tell what type it is. I have no idea what's going on. It's got a little bit of every type, right? However, if we take a step back and look at our original goal, we can see that it probably should be a coordinating function. It should be coordinating these two simple actions, getting a thing and doing something with it. But when we look at those two goals inside the entire function, that signal is completely lost. It's buried by noise that doesn't make this type of function clear. We still need to we need to extract all of those noisy actions into other well-named smaller units that can be coordinated. So this is a good candidate. Here we create this object. It's pretty noisy. It's distracting. We don't really know what kind of object we're making, and it's about 25% of the real estate inside of this function. Next, extracting our thing from that result and calling the next coordinating action. That's noise as well. The extraction is just fluff. It's getting in the way. And in the next step, we have no idea why we need to manipulate our object in this way. We don't know why we're setting some random value to 42 deep inside this object. It's just adding to the confusion. And the same is true when we update the status on the thing that we're returning. And finally, here's a big one. The shape of this code is also noisy. It's adding cognitive load. It's too hard to understand the current scope of each variable that we're interacting with inside of this function. We can create objects in line, we can manipulate them with these, and we can nest functions with just the tab key. But does that mean that we should? It's too convenient to do the things that produce noise. So how can we amplify those weak signals instead? We do that by focusing on what the function is doing. We do that because code should communicate intent. The next person to read our code isn't going to be plugged in to our current thought process, and even if you do pair, a lot of context and nuance is lost forever to time. Functions aren't a folder in a filing cabinet. They're not a place to store some procedural actions, so give those actions a proper name. Inline objects, they don't communicate intent. They're just a grab bag of properties, and they deserve a proper name as well. Names are the best way to communicate intent in our code. Names amplify signal, names give meaning, and names communicate intent. We're going to add some names to the function that we just wrote. We'll start with that initial query object, the one that we picked on earlier. It's going to become the first name in our system. Now it's clear what we're looking for. The information about what my chocolate means here, it exists somewhere else with a proper name. We've amplified its signal in our code base. And we can do the same thing inside of this function. We can give names to the confusing transition between domain concepts and when we extract our thing from the result. Now we know what's happening. It's clear that we're transitioning to a new domain concept with a name. One more time, we'll create one more name. And that's it. This is the magic. This is how you clean stuff up. You give confusing things names. You boost the signals that are already present in your code. And if you came to this talk looking for a silver bullet, this is it. Naming things is perhaps the hardest thing that we do, but it's definitely, in my opinion, it's definitely the most valuable thing that we can do to amplify signals and to reduce noise. So we've given our code some really awesome names, but they're still kind of hard to see. We need to make it clear that our function is a pipeline, that it's coordinating these well-named actions. The function's type is coordinator, so we should boost that signal to help us understand what's happening inside of it. We've got many levels of scope to think about when we look at it, and all of those levels are noisy. Since we've decided that this function should collaborate the actions of other functions, it should probably be a clean, flat pipeline. But right now it looks like a bird's nest. Some of the actions in our pipeline are asynchronous, so that means we have to start it off with a promise and use a promise chain to coordinate all of this stuff. So our goal will be to make every action a small, well-named thing inside of that promise chain. We'll start the chain by creating our query object, now that we have a name for it, and then using it in our next action when we look up our thing. Our next two actions, they become two steps in the chain. Each step passes along a promise to resolve the next value in the sequence. And if one of them happens to return a promise as well, promise.all has your back. It ensures that everything is resolved before the next step, before the next continuation. And we flatten out the last blocking in exactly the same way. This is much better. Now we have a flat pipeline. It kind of acts like a list of actions. It's very boring and easy to read, and that's a good thing. When a pipeline is boring like this, the difference is they become our signals. We're boosting the signal that tells us what we're doing in the next step inside this chain. And that's the key. Even though it's tempting to collapse a couple of the actions because they're so small, that would make the pipeline less boring, so it's a bad thing to do. So this is a boring pipeline, which is awesome, but those important signals, the important differences, they're still kind of buried. There's a lot of words and a lot of symbols getting in the way of seeing exactly each step in the pipeline. So the final test will be to eliminate as much of the CRUD as we can. We'll start out by introducing arrow functions. We don't have any weird edge cases here that will affect the way that we're using this. So what they're doing here is reducing a lot of the noise around a function declaration. They're allowing us to focus on the next step in the continuation. And next, we can bring in Bluebird, an awesome library. If you don't know what it is, check it out. We'll bring Bluebird in to clean up the chain a little bit. We'll start the chain with a new Bluebird promise, and since we started with the Bluebird promise, we get access to cool functions like spread. We'll use spread to combine that noisy promise all and the destructuring of the array that we were doing before into one clean little action. So this leaves us with a clean return and a beautiful, boring pipeline. We're actually drawn to the differences on each line now, and that's the magic. We're naturally attracted to the signals when we scan this pipeline. The values that we care about, they're front and center. They're telling us what's happening inside of this function. So we use Bluebird spread to make it happen, but it's not in this talk to show you this one cool trick to save your JavaScript, right? Spread is cool. There's no denying it. We can tell just by looking at it right here that it's awesome. But it's here because it helps us boost our signals. It gets out of the way. It allows us to focus on what's important, the return values in each continuation. And that's what an operator should do. And that's one of the powers that a functional programming language like JavaScript gives you. Of course, it's important to boost signals to reduce noise and provide useful names in your production code. Unfortunately, does that always happen in your test code as well? It's convenient to rush through tests, especially if they're written after the code, because you already know the code works, you wrote it, you tested it out while you're writing it by hand. So what's the value in the test? All it's doing right now is hurting your timeline. And if you take too long testing your code, you get to have an awkward conversation about why. So that means that the idea of treating tests as code doesn't really seem to provide enough encouragement to get it done. What I do instead is I think about tests as documentation. I think about them as my lab journal in science class, where I'm meticulously describing my experiments. Each test records my hypothesis about how a unit should function under well-defined conditions. And this allows team members to read through my test, my documentation, my lab journal, to understand how a code should function. Thinking about tests like this helps me care a little bit more when I'm writing them, and hopefully it helps you too. It gives my tests a little bit higher purpose and focuses them to help me design my code, rather than just prove that it still works once it goes to CI. And this is one of my favorite things about testing, so if you want to talk about this more, hopefully we'll have time at the end of the night to chat. Here's that messy test again. Let's give it the love that it deserves. Let's make it read like documentation. We'll start easy again, looking at the description of the test. Just like our function name, the test description is the first signal that we see. But does this one accurately describe the experiment that's being performed? Does it tell everyone what our hypothesis is about the way that our code should act? Or is it just noise that's getting in the way, that's adding to the confusion? Also, like the function name though, this is just the beginning of the story. A test needs to have 3 distinct sections. Each section needs to be clear, boring, and easy to distinguish. First you arrange, then you act, and then you assert. Keep it simple and boring here too. If we look at the test that we wrote together, this is our current arrange step. It's a mess. Which parts of this input actually control the conditions of our experiment? Who knows? Those conditions are the signal that we need to boost. It should be clear how the input to our test directly affects the unit that we're testing. That piece in our arrange step, it's just a small portion of what you actually see though. Next is the act step. This is where we perform our experiment. This entire step should be a signal, but right now it's being suffocated by the inline creation of that auth token when we call do some more stuff. We need to slim it down so that we can focus on what the action is. And finally, we assert on our hypothesis. We prove that our hypothesis was satisfied, and we ensure that our code works the way that we expect it to. This signal will be the actual values that are being tested. Don't let them be suffocated by anything that manipulates the results to make them testable. It's just going to be noise getting in the way. So if those little pieces were the signal, I guess that means that everything else, everything that's highlighted here, is just noise. The same thing happened in our test. We let convenient inline objects and distracting details weaken the signals in our code. And in order to make it better, we need to isolate those inputs that directly affect this test. We don't care about any of the extra values, and in reality, they probably shouldn't be in this test, but that's another talk entirely. We'll use them to generate a large inline object. All of the noisy extra fields, they can be merged in out of sight. This boosts our signal. This highlights the inputs that actually affect our unit. We can define a variable for the auth token, which documents its purpose. It's no longer just a raw object. It knows what it is. Now it's boosting the signal in our act step. Next, we can use variables for things whose value is important across multiple parts of our test. And when we do this, we make it clear how data is shared between those different parts. And the value of those variables, turns out it doesn't really matter. What we want to see is how they're used and not what they are. So we move them out of the test to boost that signal as well. So now we have 3 distinct sections in our test. We arrange the controlled conditions for our experiment, defining just the inputs that affect our unit. And then we act out our experiment. And then finally, we assert on our hypothesis. It's also clear which of the values in our input, like I said, are actually used in the function that we're testing. And that's awesome. So after refactoring that awful function, I'm feeling a little bit happier, and I know that the next person that's going to change this code will be happier as well. They'll be happier because they'll have a better shot at understanding what's happening. Now, when I see a mess like that, I know that my job is more important than just shipping the next feature, adding another branch to the conditional. I know how to clean up the mess. And I also know how to teach others how to do it as well. And that's not something that most people have the confidence to do. I want you to walk away from this talk today with that confidence as well. This was our before. This is what happens when we blindly accept conveniences just to go faster. And now you know what's wrong with this code. It's noisy, it's missing a lot of names, and it doesn't have a clear type. And most importantly, you know how to fix it as well. You know how to take that mess and turn it into something that serves the noble goals of quality, readability, and changeability. You can communicate intent by adding names. You can boost the signal of those names by giving your functions a clear type, and you can reduce the noise that obscures the important things in your function. This was our test before we fixed it. It's got some similar problems. It's a mess too. It doesn't have clear sections defining the steps of the test. It doesn't document how the inputs of the function affect the way it behaves. It's overwhelmed by those inline objects. And you know how to fix this test as well. You can use names to signal important pieces of data. You can document the inputs that actually affect your unit. And you can ensure that your hypothesis was satisfied under those controlled conditions. Boost signals and reduce noises. So thank you for spending your time with me today. I hope that we get the chance to talk more during this evening before I have to take the train back down to Philadelphia. If anything I mentioned today resonated with you, please send me a message on Twitter or email me so that we can start a conversation. I'm also going to be giving this talk again at SCNA on April 19th. So if you'd like to tell your friends to come watch it live at the conference, the organizers were kind enough to give us a discount code as well. It's good for 4 days. It's JS NYC. It gets you $39 off the conference ticket.
So how you're giving the example with all the promises and stuff. What about async collate? Do you find that makes things noisier, or do you feel like it's useful to use?
It's subjective. Do you think it makes it more noisy, or do you think it makes it easier to understand what's happening?
But I guess from the perspective of you like the uniformness of how all the promise.thens and .spreads look. Do you feel like it skews more towards like traditional programming and thus makes it not as good, or do you feel like?
So personally, I like it in tests a lot. I think it's nice to have that, like you said, the more traditional procedural list of actions that are happening in a task. But I like continuations a lot in production code. I like being able to just provide like the name of a function and have it do the right thing, right? I like that kind of stuff in production code. I like continuations. I like promises. But that's just my personal opinion. That's what I like. That's what to me is less noisy. I think you nailed it though when you said it's about like the consistency and the cleanliness of the chain. Was that loud enough?
Yep.
Anybody else?
All right, awesome.
Thank you.
So I thought it was pretty cool. So thank you. I caught some of my bad habits.
Awesome.
So, all right, next up we have Peter Resnick, who's from Brooklyn and working on a project called Corvo Store. Is that right?
That's correct.
And it is, well, that's actually less interesting. So we were talking before, and apparently he has an interest in parsing Russian rap lyrics.
Yeah.
So I think tonight's talk should be mostly about that. But
Yeah, 90% Russian rap, 10% Corvo Store. So.
and like 1% Redis in there.
Yeah, exactly. All right, so let me just get these over here for the demo. Correct. All right, so thank you everyone for coming today. My name is Peter Resnick, and today I'm going to be talking about Corvo Store, or how to build a Node.js clone of Redis for fun and no profit. So Corvo Store is a clone of Redis built in Node.js that I and a few other developers built. We learned a lot along the way, and I'm going to be sharing some of what we learned with you today. Before I kind of jump into the nitty-gritty of the presentation, though, I'll give a brief overview of what I'm going to be talking about. So first of all, I'll talk about what Redis is, and then briefly what Corvo Store is. After that, I'll run through a quick demo using our server and Redis's command line tool. After this, I'll address two sort of fundamental data structure level problems we had to solve during our implementation. The first of which concerns implementing the core key value structure with least recently used eviction algorithm, and the second of which concerns building one of the complex data types, specifically a set. After that, we'll kind of zoom all the way out from the data structure level to the high architecture level and follow the life cycle of a request from our JavaScript client all the way over to the server, through the different structures in the server, then back to the client again. Then finally, I'll address some of the many limitations of our current implementation and talk about a few possible next steps. So just as an aside, this is a pretty data structure and algorithm heavy presentation. So if at any point a question occurs to you, I'll try to pause periodically throughout the presentation and address them. So that being said, I'll move on to the first point here. What is Redis? So Redis is an open source, largely open source in-memory key value store. In other words, it's a dictionary-like NoSQL database that sits in memory and is extremely performant. Redis features a variety of eviction policies, but one of the most common or one of the most popular eviction policies is what's called least recently used. I'll talk about this more later on in the presentation, but for the time being, think about one of these eviction policies as an algorithm for determining what data is flushed out of the store, basically out of the database when the database is full. Redis also supports complex data types in the value space. So if you imagine a dictionary, normally you would have a unique string identifier mapping to a string value, but Redis actually supports complex data types in the value space. You can have a list, a set, a sorted set, and so forth. And then finally in my bullet point list here, Redis supports a variety of optional on-disk persistence. What is Redis used for? Redis is a highly specialized backend tool. It's often used as a session cache, a full page cache, or as a message broker, which is basically the database will sit in the backend and coordinate operations between different services or microservices operating back there. So now that I've talked briefly about what Redis is, I'll talk about Corvo Store. So what is Corvo Store? Corvo Store is an experimental project developed by myself, Kalyan Vidala, developer in Atlanta, and Preeti Viswanathan, developer in the Bay Area. Our goals in building Corvo Store were not to build a production application. Of course, this is experimental software, sort of for our own edification, but we wanted to actually figure out how Redis works. We're really impressed by Redis's performance, and more specifically by the time complexity on a lot of Redis operations, which seem almost magically fast. So this is kind of the second point. We want to learn more about the data structure level implementation of the store itself, and then the complex data types. Finally, we wanted to experience the challenge of developing a non-trivial application to demanding specifications. To this end, we implemented Corvo Store, which now exists as 2 NPM modules. The first is a JavaScript client, and the second is a node-based JavaScript server. This project is completely open source. I'll have links at the end, but if you want, you can go and poke around in the code, or you can go and download the modules and use them, spin them up, see what's going on. Again, not a production application. I wouldn't recommend incorporating this into anything that you're planning on building and exposing to the public. But now that I've kind of talked about Redis and Corvo Store, I'll run through a quick demo of, here, let me just get to the terminal window here. I'll run through a quick demo of the server using using the Redis CLI tool. So here, as you can see, we're located in the Corvo server npm module. And so I'll just start the server here with an npm start command. So you can hear it's spun up. It's sitting on localhost at port 6379, which is actually the same port that Redis sits on and operates on. And then here on the left, I'll spin up the Redis CLI. Oops. So as you can see now, the Redis CLI has come online, and it sent a quick confirmation message over to the server. Our implementation of Corvo Store actually, since it sits on the same port and makes use of the same client-server communication protocol that Redis does, we actually have full interoperability between Redis clients and our server, and vice versa. Well, full interoperability to the extent we implemented the Redis commands. So here on the left, again, so this is the command line application. So say we want to set a string value in the store. What we would do here is we would use the command set, and then say I want to store my name. I would set my name and then whatever value I actually want to input. So if I do this, you can see over there on the right, this is sort of debugging code. I guess I don't know if this is signal or noise, but anyway, here this is what's output into the console, and as you can see, that's been received. It's been parsed, successfully written into the store, and then actually appended to the AOF file on disk. So the AOF file on disk is one of the ways that Redis addresses persistence. I'll talk more about this later in the presentation. So here now, if we want to get it back, we can just do get my name, and then we get Peter Resnick back here in the console. If a developer were using a client, this value would be returned into whatever the execution context was for the client API. Redis also supports complex data types. Say we want to create a list. We could do lpush. We'll just call it my list. Very creative naming today. And then we'll push 5 integer values into it. So again, you can see it's been received, parsed, written into the store, and written into the disk there on the right. Now, if we want to perform operations on this, say pop some value off the left or the right, we could do lpop my list. And as you can see, these values are being popped off. So say now, for some reason, we want to simulate a server crash. So I'm not actually going to do that, but let's just shut the server down. Now you can see there's nothing running here. So I'll exit the CLI, then go back over here, and I'll start the client up again. So under normal circumstances, if you have an in-memory database, when the database crashes or stops running, everything in state just disappears. But Redis actually implements a sort of a fail-safe persistence that stores all of the right operations and then puts them back in the store if the server is spun up in a directory where this specific type of file is located. So now if I start the Redis CLI again, so now as you can see, we're communicating there, and so we should still have a few values in the list. So if I try and now rpop something off of my list, as you can see, the values are still there. Now if I do that again, we'll return nil because the list is actually empty. So in short, this is sort of how the server works in conjunction with a command line tool. Now that we've discussed this, I'll see. Man, this is difficult to manage over my left shoulder here. But anyway, yeah. So now I'll move this off to the side and return to the presentation proper. So now that we kind of have a sense of how Corvo store works in conjunction with the command line tool, we'll move on to the first discussion of the data structure level problems we solved, which is the implementation of the core key value store. Actually, I don't know if anyone has any questions about the demo, but if you do, you can answer now. If not, okay, cool. We can move on. So the first question we had to answer when we started off thinking about this project and building it was how to actually implement a core key value store structure that features least recently used key eviction. So least recently used key eviction, as I said before, is just an algorithm for deciding what data to flush from the store in the event that there's a memory overflow. But it's kind of an abstract presented in this way. So I'll run through so after this I'll run through a demo of that. But for the time being, this is sort of what we had to think about first. These are the constraints we had to think about when building the server. So Corvo store, this core structure has to be a dictionary, so it has to be something similar to an associative array, where you have a set of unique key values that map to not necessarily unique values in the space. It must meet Redis's performance criteria, so it must have constant time lookup, insertion, and deletion. And then finally, since we're going to implement the LRU algorithm, it has to be memory limited, and it has to have some system in place for flushing least recently used data. This LRU algorithm, though, is a bit complex. So before we actually get into any of the data structure level stuff, I'll just walk through a quick demo of how that would work. So say we have a store that can hold at most 3 values. These values are 100, 200, 300. Don't actually have to be sorted. That's just kind of happens this way. So in order for LRU to work, we need to have the values, and then we need to maintain some means of tracking what's called the touch order on the keys or the values themselves. And the touch order in this context, touch in this context means whenever a key and a value is read, updated, or created in the store. This is basically what a touch signifies. So here we have 3 values, and then you have the touch timestamp there at the bottom. So say I want to read the first value, I do that, and the timestamp is updated to reflect the fact that I've read it and touched it. And so as you can see here now, the value 100 is the most recently used value, 300 is the second most recently used value, and then 200 is the least recently used value. So we have this here. Say now that we want to add a new value, 400. Well, we can't simply write it in because we can only store at most three items. So what are we going to decide to remove from this store? We're going to pick the value 200 because 200, as is shown there by the timestamp, is the least recently used value in the list. So we delete this from the store, we write in 400, which as you can see by the timestamp now is the most recently used value, and this is in a nutshell how the least recently used algorithm works. Yeah, so before moving on to our hypothetical implementations, I'll pause and see if anyone has any questions about LRU. If not, then I'll move on. So first hypothetical implementation that we considered sort of from a data structure perspective was a simple array. Whenever you have a collection of elements, you want to think, maybe we can get this done with an array. Will an array work? So right off the bat, we know that it won't. Because in order for us to maintain our uniqueness rule on the store, we have to be able to determine uniqueness in constant time. Even if you have a sorted array, it's not feasible to figure out whether an element is already present in the array in constant time, so we just have to reject this. Even if it were sorted somehow, the best you can get really is logarithmic time. So we have to reject it on these grounds right off the bat. This kind of leads us to our second potential implementation, which would be a hash table. So in contrast to an array, a hash table actually does allow you to check for uniqueness in constant time, and it allows you to look up a key value pair in constant time. However, we can't determine the LRU key in constant time, because if we're using a hash table alone, we would need some kind of value that denotes ordinal value stored in the value space itself. So in order for us to actually figure out the touch order for the keys, we need to iterate over all of them, or at least a portion of them. And again, this isn't a constant time operation, and for this reason, we have to reject a hash table alone. But what if we combine a hash table and an array? So here, we have a hash table on the left, and then an array functioning as a queue on the right. The idea here is that we would get all of our dictionary properties, the uniqueness, the constant time lookup, and so forth from the hash table, but then we would maintain the touch order there with the LRU array on the right. So we can look up a key value pair in constant time. We can determine LRU key in constant time, but unfortunately we can't touch a key value pair in the LRU array in constant time. Again, because an array as a data structure has to maintain contiguous space in memory, we don't necessarily know that the key we want to touch is always going to be the key at the tail of the list. So if we want, for example, if we just do a read operation on my key, in order for us to maintain the order, we would have to then move my key from the 0th index to whatever the tail index is. This, of course, would be a linear time operation, and since the touch accompanies all of the other operations performed on the hash table, we have to actually reject the third hypothetical implementation. So we probably know at this point that the hash table is what we want to use, but is there some kind of data structure that encodes ordinal values, but also allows for constant time movement? Turns out there is. That data structure is a doubly linked list. So this is our final implementation, the successful one. If you're ever in an algorithm problem, this is what you should do when they ask you to build an LRU cache. But basically, the hash table stores all of the keys, and then the value associated with the key is a reference to a place in memory. And the location in memory then holds a node in the linked list. Basically, as you can see here, the arrows map from the value space over to the node. So that is the corresponding value for the given key on the left. Then in the main linked list, we sort of have a structure outside that maintains references to the head and the tail. The head is the least recently used value and corresponding key, and then the tail is the most recently used value or corresponding key. This again is kind of a complex data structure, so I'm going to walk through a few different operations to show you how it would work in practice. So the first operation we'll do is just accessing a value. So here we have the state as it existed before, basically when I was talking about the demo. say we want to perform a read on my key 1. So that's fairly straightforward. We hit the main hash with the key that we want to look up. We get the reference to the node. We get the value from the node, return this to the developer in whatever context the developer wants it. And then we perform a constant time node movement in the linked list. And so my val1, the node that's wrapped around that value, is moved from the head to the tail. So now my val1 is the most recently used node, and my val2 is the least recently used node. So this is how we would access a value. Say we want to add a new key value pair, though. So the first step in this process is instantiating a new node in the linked list, into which we write the value itself. Then we set this as the tail on the linked list, basically signifying now that some value, and not my value 1, is the most recently used key. After this, we write the key into the hash table, and we set as its value this newly instantiated node. So let's say, though, that we've happily created this new key value pair in the store, but what we want to do now is actually, that's strange. I think there's some, well, normally that should be grayed out. That's not supposed to be white. But in any case, let's say that when we add this new value to the store, it ends up exceeding our max memory allocation. This would trigger an LRU deletion, and so how would this work? Well, we know whatever is at the head of the linked list is going to be the least recently used key, and we have a reference to this in our linked list structure. So we hit the structure, get the head, delete that node from the list, get the key off of the node, because in our implementation we actually store the corresponding key in the node, and then we delete that key itself from the hash table. So this should be gray here. Instead, it seems like it's white or very difficult to see. But in any case, that is what we remove. And then finally, that's taken out of the store. And this is our final state. We maintain all of the keys that we're interested in still in the hash, untouched. Values are in the linked list untouched. But the order of the nodes in the linked list actually denotes the touch order, which we've preserved over the course of all these different operations. So yeah, this is the core data structure. Before I move on to talking about complex data types, I would pause and see if anyone has any questions or comments about this. If not, I'll move on. So Redis supports string values in the value space, but it also supports complex data types. These can be lists, sets, sorted set, even more abstract data types that you could use, for example, to store like geolocation values. But we ended up only implementing 4. We implemented the list, hash table, set, and sorted set. Although the implementation of all these different complex data types was fairly interesting, in the interest of time, I'm only going to focus on one, which is the set. So the set. So what is a set in Redis and more generally in computer science? A set is a collection of unique non-ordered string values which are referred to as members. So this first off is sort of the basic constraint of the problem. In addition, Redis sets a number of time complexity benchmarks for operations that you can perform on the set. So insertion into a set has to be done in constant time. Search has to be done in constant time. And removal also has to be done in constant time. Redis supports two kinds of removal on the set, random and targeted. Targeted removal happens when the developer has a specific member in mind. They pass this member in, and then it's popped out of the set. But random removal happens when the program basically algorithmically picks a random member and then pops that random member after the set. Random removal actually turned out to be the most tricky of all of these to implement and led us to our final data structure. But before we get there, we'll talk again at the hypothetical data structure level implementations. So the first naive implementation here, as usual, is an array, right? Could we use an array to represent a set? So we can push to an array in constant time. So that means, in theory, we could perform insertion into a set in constant time. However, we quickly run into problems. We can't remove from an array in constant time because if we're doing constant targeted removal, we don't actually know where the member will be located in the array. And additionally, we can't search in an array in constant time, again, for the same reasons that I briefly touched on earlier. So right off the bat, we have to reject an array. We could also, in theory, use a hash table. And initially, a hash table seems like it would be the perfect data structure. We can write to a hash table in constant time. We can search and remove from a hash table in constant time. And we can also, however, we can't perform random removal from a hash in constant time. This is because it's difficult to actually track all of the keys in a parallel structure. You can't simply get them from a hash table kind of by its nature, regardless, specific language level implementations notwithstanding. So basically the question became how we can perform random removal from a hash table in constant time. And our solution was this fairly Baroque data structure you see here. The general idea here is that we have two hash tables in parallel and then a single value which stores cardinality. So the hash table on the left, which I've called member hash there, stores all of the members as keys and then has as value an integer representation of the cardinality of the set after the insertion was completed. So for example, presumably the set was empty, we inserted member A into the set, and then the value for that member is set to be 1, which is the cardinality after the insertion happened. This structure over here on the right basically represents the reverse. It maps from the cardinality after the insertion to the member. And then finally, we store the cardinality value separately because it has sort of a distinct role to play in some of the algorithms and the structure. The value of this parallel structure is that we can basically figure out the cardinality with only the member, and then we can also figure out the member if we only have the cardinality. Again, this is kind of abstract, so I'll walk through a few different operations in order to give you a sense of why this was necessary. So if we want to add a new member to the set, this is actually pretty straightforward. The first thing we do is increment cardinality. Then we set the cardinality as the value for the member in this member hash on the left, and then we basically do the reverse for this integer hash on the right. Say, however, that so we've done this, and now we want to actually randomly remove a member from the set. This is a much more complex process. So the first step here is generating a random integer between 1 and cardinality and then storing it. Next, we look up the member associated with this random integer here. So now we know that the random int is 3 and the member is going to be member C. After this, since we have both the integer value and the member value, we delete both of these keys from the member hash and the integer hash respectively. Normally we'd think, oh great, we're done now. We've deleted the unnecessary data. Everything is hunky dory. But unfortunately, that's not the case. This is kind of the rub of the problem. In order to be able to consistently generate a random member, we need to maintain a contiguous range of integer values. And right now, we don't actually have that. We have 1, 2, 4, 5, as you can see. So the remaining steps in this process all involve basically addressing this deficiency and making the range of integers contiguous without losing any of the members. So the next step here is to write the member reference by cardinality in the integer hash to the stored random integer and integer hash and a member hash. So in other words, we know that we're going to have to put some value at the slot that we deleted the value before, which is the integer 3. So we get the member at cardinality, which is 5, and so we set cardinality's value to be 3, and now we've reconstructed the contiguous range of values in the value space in member hash. The next step here is to replicate this from integer hash. So now we know that we have 1, 2, 3, 4, 5 on the integer hash, but we only actually have 4 members, despite the fact that the cardinality is still 5. So what we do is we delete the value at current cardinality, which is actually now a duplicate of member E, as you can see there. And then after that, we flush this value out of the integer hash, we decrement cardinality, and the random removal operation is complete. So this is sort of a data structure level implementation of the set. Next, I'm going to move on to a discussion. We're going to zoom out and look at the overall arc. Oh yeah, sorry, go ahead.
Yes. Well, first of all, this is fascinating stuff.
Sure.
My question is this how Redis works?
So Redis is implemented in C. I personally am not comfortable enough to C to actually dive into their source code and figure out what the data structure level implementation is. So sometimes Redis actually has really comprehensive documentation. So in some cases, they basically say in the documentation what data structures they're using under the hood. So for the sorted set, for example, their implementation, which we ended up replicating, is a probabilistic data structure called a skip list used in tandem with a hash table. With the set, though, they don't actually go into detail about what the solution was. So I just kind of thought this up. So the reason the set was interesting relative to the sorted set actually is, again, because we have this random removal operation that's performed in constant time. So all of this additional hash table and even the cardinality value are necessitated by the need to implement random removal in constant time. Generally speaking, Redis is very, very fast, and it really optimizes time complexity over space complexity. And so I don't know how it was implemented, but I think basically doubling the space complexity effectively in constant terms anyway would be acceptable in keeping with their philosophy. But I don't actually know how Redis implemented the set on the C level. Yeah, cool. So moving on, we'll take a sort of a higher level architecture view of Corvo store by following the life cycle of a single request. A string set request from our JavaScript client over to the server through all the various structures in the server and then back to the client again. First of all, this is the architecture of Corvo store. The way this next section is going to work, we'll have sort of a high level map, and then the section where the action is happening will be circled in red. And then in some cases, there'll be a little code snippet to the left, and that code snippet is the actual JavaScript that we use to implement whatever it is that I'll be talking about in that particular slide. So the cycle that we were talking about before, writing a string value into the store, begins with the JavaScript client. This is one of the API methods that are exposed to the developers. So we would invoke one of the client methods, in this case async set, and then pass in the data we want written into the store. Inside of the method, the actual write operation is asynchronous. It creates a promise and ultimately only returns the server's reply data after the asynchronous operation resolves. So in other words, all of the subsequent operations in this process, everything that's happening over here in the server, that's all going to happen before this function itself returns. In order for the client to send data to the server, however, it first has to be encoded into what's called RESP format. What is RESP format, you ask? RESP format was developed by Redis, and it stands for Redis Serialization Protocol. It's basically a simple text-based protocol that describes how every request sent from a client to a server or from a server back to a client should look. It's pretty simple. Here, the first section up here, this tells us the total number of tokens that should be in the request. And then after this, we have these pairs of $ integer followed by some string value. And the first here corresponds to the length of the token, and then after that is the actual token itself. So as you can see here, we have 3 total tokens: the command, the key value, and then the string value itself, and the corresponding lengths of each of those. So this is how REST works. So in order to actually do this, the client sends the data to the encoder. And the encoder handles the process of transforming the raw data into a properly REST formatted string that the server will understand. After this string is generated, the client prepares to send a request to the server. The client creates and returns a promise. As you can see here. Inside of this promise, the actual asynchronous write operation takes place. We handled all of the writing across the TCP/IP connection using a Nodes net module, which is built in, makes it very easy to spin up a TCP server or send TCP level requests. This is the actual promise I was referring to a few slides ago that will ultimately resolve and return the string back to the developer. So after the client writes the request, it travels over the magic of TCP/IP to the server. The server handles the request by means of an event listener that is set every time a new connection is established between a client and a server. Whenever the connection emits a data event, which is to say whenever the client actually sends data to the server over TCP/IP, the listener invokes the callback. And then this callback is actually what processes the REST request data. After extracting the REST string from the client request in the callback, the server passes it to the parser. The parser has a few different responsibilities. The first responsibility is to check that the REST string is properly formatted according to REST protocol. After it does this, it checks to make sure that the properly REST formatted string actually kind of makes sense from a business logic perspective. So in our case, what the parser is going to do is it's going to make sure everything in the REST string is pretty, and then it's going to make sure that there are 3 tokens in total, because we have the one set command, and then we have the value and the key and the value after that. We also have to handle flags, but that's sort of a different, more complex issue that we don't necessarily deal with here. So after the parser has basically validated the data from the client, we turn to the question of putting the data into the store itself. So the parser actually, so I guess now to return to the clean code, this is sort of like a controller. It's wearing many different hats, so it might actually not be the best organized or the best written. But in any case, the parser is responsible for validation, and it's also responsible for controlling the methods that are ultimately called on the store itself. So in our case, it will execute the method for writing a string value into the store. This is setString here. So this store method is where the data is actually finally taken and written into the LRU structure that we're talking about all the way back, the key store with LRU structure we were talking about all the way back at the beginning of the presentation. An important part of this, however, is actually dealing with memory. Because Redis, especially when it's used as like a backend cache, a least recently used cache, it needs to know what the max memory is, and it needs to know how much memory it's actually dealing with at any given time. So after the write operation happens, we turn to this issue of memory tracking. So many different types of changes in current memory allocation are possible. Write requests, however, often instantiate completely new key value pairs in the store, and that is what the code here deals like. And this is kind of a really ugly, it's like a really ugly code snippet with a lot of maybe extraneous commenting out. But in any case, got rid of all the extraneous code, and this is the case where we're dealing with a string value that's being written into the store. So basically, the memory tracker gets the command and the values that are going to be dealt with, and then it figures out how to increment or decrement or not at all change the server's current approximation of memory allocation, and then it performs this change. So after this, after we've written the data into the store and we've addressed the issue of memory allocation, we turn to the question of persistence. So like Redis, Corvo Store supports what's called AOF persistence. AOF persistence is a journal style form of on-disk persistence, where every successful write operation is basically the request itself is saved and then appended to the end of a file on disk via an open write stream. Then in the event of a server crash, like the crash I simulated in the demo, you spin the server up again, and if the file is present in the directory, the server basically takes it, breaks all those requests apart, and then runs them again super quickly. And in this way actually manages to reconstitute the state of the server at the moment of the crash. So basically, in order to figure out whether we need to actually write to the disk on file, 2 things need to happen. We first of all need to figure out whether or not the command is a write operation. That's what all of this logic here is about. And then we also need to figure out whether or not the write operation was successful. So if it is a write operation and it was successfully executed on the store, then we basically save the request and append it to the end of the file on disk. And that is sort of the responsibility of all of this code. And then this is the open write stream here. So after addressing the question of persistence, the time comes to prepare whatever the response data is and send it back to the client. Basically, this response data is like a status report from the server that tells the client whether or not the operation was successfully performed. The server actually, so we don't have separate structures here. We didn't actually decide to break them out on the server side in our diagram. But basically, this section of our architecture here takes the tokens, encodes them again into REST format, and then sends them back across TCP/IP over the original connection to the client. Once the client receives this string, the process isn't quite complete yet because it's still REST formatted. So the string is taken, sent to the decoder, and then here in the decoder, we basically check to make sure that everything was properly formatted and it was executed properly. And then after that, the decoder basically parses the string, breaks it into the necessary tokens or the necessary values, and then returns these back into the original context in which the developer invoked the API method. And that is the life cycle of a single request from the client through the architecture and the server, and then back to the client again. So I'll pause here again. Are there any questions? If not, yeah, sure.
You mentioned you're using a journal file system.
Yeah, for the AOF persistence, yeah.
But the cost of your cracks is one of the operations. Can go back to that.
Yeah. So there's some possible data loss there. I mean, like the AOF style of persistence is imperfect for a number of reasons. I mean, there could be some corruption, but generally, the main use case for this style of persistence is an LRU cache, and so it's not hugely important that every single write to the LRU cache is saved. So basically, the idea is you want to reconstitute the majority of the state, like the overwhelming majority of the state, so that it continue functioning as a cache in the broader context of whatever the application is or the system is in the back end. But losing a single write request is not hugely important. You can basically start the cache up again, and it will perform its function more or less efficiently. But you are correct. There is the possibility for data loss with AOF. Cool. Yeah, so now I'll we've gone through this whole process, and I'm not sure I'm doing on time, but I'll briefly go through some limitations in the current implementation, and then possible next steps that we can take to address those limitations. So the first limitation, and one of the most significant ones, is that our memory tracker actually only provides an approximation of memory used. JavaScript is a high-level language, and the actual memory allocation is handled by a garbage collector. And this garbage collector is handled even further back by the V8 engine. So not only is memory allocation kind of addressed in this iterative fashion, which isn't very useful, it's handled in this really opaque way by this sort of back-end task that's running in V8. So it's really difficult to figure out what's going on. It's also kind of weird. Apparently, the memory allocation for an object in JavaScript depends on the number of objects instantiated in the runtime at any given time. It's kind of difficult to figure out. But in any case, our current approximation is not completely accurate. It's just an approximation. So we would like to make this more accurate. Maybe by using APIs on the V8 engine, or maybe by actually going somehow to the system level and seeing what memory is allocated to the process itself that's running the server. The second limitation is that we just only have a single JavaScript client. It would be cool to have clients in other languages. Like if we make a Ruby client, we would have Rails compatibility, which would be nice. It would also be cool just to make a command line client, just because I think they're really neat. That's another limitation. Additionally, Redis has a large number of eviction policies, but we only have least recently used. However, if we were going to implement a lot more of these, we would need to sort of implement as well what's called key expiry. This is sort of another issue, but the basic idea is that when a developer using Redis writes a key into the store, he or she has the option of setting a time interval after which that key will expire. A lot of these additional eviction policies depend on that functionality, so in order to build those, we would need to build in the expiry first. And then finally, sort of to return to your question, our implementation of AOF persistence is actually pretty flawed. But it's not for the data corruption reason, it's just for the reason that we don't actually optimize for space at all. So if you consider the number of write operations that could be performed to Redis or to Corvo store in the span of a minute or 5 minutes or an hour, and then if you think, well, we actually need to keep all of these basically as string values at the end of a file on disk, it's pretty easy to see how this could very quickly become almost an insupportably large file, like a system level problem. So Redis has two approaches to addressing this, both of which are actually pretty interesting algorithmically. The first one is kind of intelligently parsing write requests as they come in. And so, for example, Redis has the functionality, and we with Corvo Store also have the functionality of incrementing a integer held as a string value in the store. And so what this intelligent parser would do is to say I increment this string value 1,000 times with an increment of 1. This intelligent parser would say, oh, this is equivalent to a single increment request with an increment value of 1,000. So basically those 1,000 values would be compressed into a single one, and then only this one would be appended to the end of the file on disk. So that's one approach. The other approach is implementing what are sort of called AOF persistent snapshots. And what you would do, or the way it works in Redis, as far as my understanding goes, is that periodically, at some interval set by the developer, Redis will create a parallel process, and then this process will iterate over all the keys and values in the store. And then for each of these keys and values, Redis will generate a write request that would basically reconstitute whatever the value is if it were run on the store at that given time. So what this parallel process does is it runs through all of the keys and values, reconstituting, basically creating a request that would push whatever the value is currently in the store into the store if it would run again. And then after this process is complete, this new file is taken and it overwrites the existing journal style file, and then all of the write requests performed in this interval are taken and appended to the end of this new snapshot file. This kind of seems like it would be very complicated, and creating a file that has one write entry for every key in the store doesn't seem like it'd be terribly efficient, but if you actually, again, think about the number of write requests that a tool like this is supposed to handle, it actually is, in fact, an optimization. I think both of these would be really hard to do in JavaScript because JavaScript is single-threaded, so it's kind of hard to do like not parallel processing, but it's hard to do work in parallel, different tasks in parallel in this way, but those are two potential approaches. And that's my presentation. So thank you all so much for listening. Again, this is an open source project, so if you go to my GitHub there, you can find the link to Corvo Store, poke around in the code. We have a write-up on the project at the github.io file up there, which actually goes into more detail about some of the other data structures, and then finally, we have 2 NPM modules that you can download and play with well. So if anyone has any questions, happy to answer those now.
I know Redis does like multi-operation commands where it won't execute until all commands are.
Yeah, so we don't do transactions. Yeah.
So
yeah.
Could it support though, like in the future, do you see your code base being able to kind of adopt that?
Potentially, yeah. I mean, I think it would depend on the bandwidth that I have and the other contributors to the project have. But yeah, I mean, I think we could theoretically work that in. It's a pretty complex topic though, so it would require a fair amount of work. But yeah, we don't support it now, but it would be cool to build in. Yeah. Any other questions? All right, cool. Thanks again. Really appreciate it. Just as a side, I'm currently in search of full-time opportunities, so would love to talk with anyone about that. Please feel free to reach out to me about the project or about that after the meetup's over, or by email here. So thanks again. I really appreciate your time.
That was pretty cool. All right, and our final speaker, Ignacio Fuentes. He is a senior sales engineer at Telerik. So we're okay. And he's got socks for everyone that wants. Not everyone, but for those that want them. So if you do want socks, I think it'd be interesting if you had to say something. So, it doesn't have to be a question, maybe.
I'll take socks.
Yes, please. Go ahead.
I already have the t-shirt.
Oh, really? Okay. Well, thank you all for joining. So we're going to talk about NativeScript today. In particular, we're going to talk about NativeScript and how you could sprinkle some machine learning on top of it to add a little bit of flair to your application. So show of hands, who knows about NativeScript at all? A couple of people. All right, so let's actually cover what NativeScript is in the first place. My name is Ignacio Fuentes. Like they said, I'm a sales engineer for Telerik, but we got acquired by Progress, so you can say whatever, Telerik Progress. So NativeScript. NativeScript is an open source framework for building truly native mobile applications. And what we mean by that is that you can build native apps, completely native apps, not Cordova apps, not HTML-based apps, but fully native apps in a cross-platform way. And you can actually reuse many of the popular frameworks out there, like Angular, like Vue, or in fact, we don't require you to use one. You can use NativeScript as what we call vanilla NativeScript, so no framework at all. So it's very cool because you can write JavaScript, you can write TypeScript, you even write CSS to style the applications, and you can reuse any of those popular frameworks out there. We currently target iOS and Android. Those are the two big ones. If something else big comes along, we'd probably support it as well. So we'd like to think that it's the best tool for cross-platform native app development. There's 5 reasons that we could list. First of all, you get rich, animated, no-compromise native UI. And you'll find there's quite a few samples out there that can help for that, to kind of bring that concept to reality and to your screens. We have a few apps that are in the App Store you can check out. Like I said, you can reuse a lot of skills you already have. You already know JavaScript for sure, because you're in this meetup. You probably already know NPM. You probably already know TypeScript, Sass, Angular, etc. So you can reuse a lot of the skills you already have, but you're going to be building a native app. You also get to target a lot of architectural choices. At first, we were just vanilla NativeScript, nothing in particular that we would support. Then we added support for Angular, and then the community actually added support for Vue, and now we have, in a way, adopted it as an official framework that we support as well. So now we support both Angular and Vue and the vanilla approach of NativeScript. The other thing is that you get to use native things without having to ever write Swift or Objective-C or even Java if you're targeting Android. It's very easy to do native things in full JavaScript at all times. So for instance, let's take a look at this snippet of code right here. What NativeScript has done in an engineering fashion, first of all, is that we have mapped 100% of the APIs. So that means that any class, any namespace, any property, anything that is available in the native SDKs is available to you in pure JavaScript. Now on top of that, if you can think about it, right? If I write something like a UI alert view or something like that in JavaScript, it'll work, but that won't work for Android. So what we have done is we've created wrappers for the common things that you'll find in all of these platforms. So for instance, if I want to create an instance of a file to work with the file, do something, I simply import the file module that we've created, and that internally will handle, and again, the code that you see below is also JavaScript code. That will internally create an instance of a java.io.file with the constructor, passing it the path, and it will also invoke the ns-file-manager.default manager that would be the equivalent in the iOS world. So with pure JavaScript code, you can either write, you can make use of the modules that we've made available, and if you ever were to need it, you have access to the full APIs. Any class, any property is available to you in pure JavaScript. We also have created a markup approach for creating UI. So for instance, if we see right here, something very simplistic, but this is a switch, and in the actual screen, if you're on an iPhone, it will look like the iPhone switch because it is the iPhone switch. It's not in any way a little HTML switch that we've created and we've just styled it with fancy CSS. That is the switch that comes out of the box from the Apple SDKs. The same for Android, of course. And there's switch is just an example. We're talking about buttons. We're talking about list views. We're talking about tab views. We're talking about side drawer navigation, nav bar, etc. All that stuff you can write in pure markup, and that way you define a UI that is cross-platform, works on both iOS and Android, and in the code behind you'll be writing JavaScript or TypeScript or whatever. Of course, there's also a big marketplace of plugins. So, things that are probably not going to come out of the box, but you require some kind of integration from different kinds of SDKs. We have, we call it a curated marketplace of plugins that you can use. And everything is really handled through NPM. We just created fancy websites to only browse NativeScript plugins, but in reality, they're just NPM packages. You also get to reuse any existing CocoaPod or Android Arsenal library. The reason for this is that the way the NativeScript works is that it maps whatever it sees. It's not like we did all the busy work to go one by one on every API and we mapped it into JavaScript somehow. NativeScript itself, the framework, iterates through the metadata of all these libraries, and then it injects those APIs into your JavaScript runtime, essentially, so that you have access to all those variables and classes and properties and methods, etc. So that will apply to what comes out of the box with the SDKs, and it will also apply to any library that you add into your application. And that's why you can use any CocoaPod library or any Android Arsenal library in your NativeScript app. Also, we have a vibrant and growing community. We have, of course, a discourse where, it's a forum where people are asking questions, and it's growing. And we also have a Slack channel, which has, as you can see there, this might be a little bit outdated, over 4,000 people discussing NativeScript. So you'll get an answer very quickly for any issue that you run into. And the final thing is that NativeScript is fully open source, free and available to anybody. But it's supported by a major corporation, which is Progress Software. So you have the assurance that we're not just going to abandon it. NativeScript is an important factor of the future of the company. So it's not a framework that you're going to pick for your next mobile application project, and we're going to ditch it. It's going to stay around for a while. Now, machine learning is what we wanted to add as a little bit of a sprinkle into this conversation. The reason is because you don't just want to create boring apps. You probably want to add some kind of interesting functionality to it. And machine learning is something that we see is getting a lot of pickup. So it'd be cool to add something like that to your application. So of course, it's very simple, right? You only need to know a little bit of batch gradient descent and stochastic. I'm sure that the guy that presented before probably knows all this stuff. But no, we're not going to be covering any of this today, luckily. But if we want to know, the basics of what machine learning is you can think about it as a way to give computers the ability to learn without being explicitly programmed. In a little bit more of a scientific definition, you can say that a computer program is said to learn from experience E with respect to some class of tasks T and performance measure P if its performance at tasks in T as measured by P improves with experience E. A little bit of a scientific definition, but it gives us an idea of what machine learning is. In a way, you can think that you can do machine learning by gathering a lot of data. And since we're talking about mobile applications here, a phone is really in a great position to gather a lot of data, and that can be images and sounds. You can, to perform a machine learning experiment, if you will, you'll divide that data into a training set and a test set. So the training set you categorize, because you know the categories prior to the experiment, and then you have a test set that is not categorized. So you create the algorithm to train the model with the training set by pairing input with the expected output. So you use the test set to test the accuracy of the training, and then of course you tweak your algorithm, and essentially you'll improve at that. And the algorithm is supposed to get better as you do that, and the more data, the better, of course. So, of course, we already see good uses of machine learning out in the wild. I don't know if you've heard of Stitch Fix, but this is a fashion company, essentially. They ship you clothes, and they combine, of course, human interaction and human curation, but they use a lot of advanced formulas to pick out clothes based on customer input. They use formulas to pair a shopper with a stylist, formulas to calculate the distance of a warehouse to a customer, and algorithms to search and classify clothing trends to recommend. So this is a cool use of machine learning, but of course there's also some scary things that you can do with machine learning. So we want to be careful and not recreate Skynet. For instance, there's some scary uses of machine learning. I don't know if you've seen this this video that became a little bit of a trending topic a couple of months ago. This is what the Chinese government is doing to basically track people on the streets. We've also seen we've seen videos of how they can just use expressions, facial expressions, and then recreate other people's faces, so they can kind of create videos of like, oh my God, this guy said that, and it's totally fake. So machine learning, it's something that we need to be a little bit aware of. There have been some philosophers and scientists kind of raising the alarm of what it can do. I think it was Bill Gates that said something about it, Stephen Hawking, Sam Harris, all kinds of people are saying that, AI is something that is cool, but we need to be a little bit careful of, doing it responsibly. An actual example of this is MIT students use mapping data and crafted an algorithm to optimize school bus routes, and they determined that there were 50 superfluous routes, and they eliminated them. It was up to $5 million saved, but a bunch of people lost their jobs because of that. So, well, I don't know if I'll leave that one up to you, but this is what I call the gray area of what machine learning can achieve, because it did save some money, but put some people out of work. Now, like I said, doing it yourself can be a tricky thing. You need a lot of skills, you need firepower, but the good thing is that there are some solutions out there. There are some local solutions that you can use, and there are some cloud solutions that you can use. Well, we're Microsoft, and of course, I have to mention that Microsoft has a cognitive services suite that they offer, and it's very advanced. It allows you to analyze images, process language, process audio, give information on the things that it processes, and it's very advanced. Google, of course, also has their cloud platform. There's Clarify. There's quite a few solutions out there that are very useful. So I wanted to actually build something, show a little bit of what NativeScript can do. So bear with me for a second as we do that. So NativeScript, the way that you get started with it is essentially via a CLI, and hopefully you can see my screen.
Can you biggerize it?
Let's biggerize it. All right, so the command to get started with NativeScript is TNS. TNS stands for Telerik NativeScript. And the first command that we want to use, of course, is the create command. We give it a name. Let's give it a cool name. That's what I can think of right now. And we can actually use this --ng because I want to use Angular for this application. So the first thing it's going to do is going to pull down the hello world ng template that we have. So it requires a little bit of internet to get started, but with that created a folder, and we can actually, right off the bat, run that as an iOS app. And in the meantime, I will open that in VS Code. So the run iOS command, what that is going to do is essentially build the application. So your NativeScript app is going to be an Xcode app as any other iPhone app. When it comes to iOS, of course, it would be a Java project if I'm building for Android. But what it is really is going to be the NativeScript framework in there and the JavaScript code. And then everything happens at runtime, essentially. But when you actually compile it, it is going to compile, in fact, using Xcode build. And this is why, by the way, if you're building for iOS, you do need a Mac. If you're on a Windows machine, you can, of course, build for Android. If you want to target iOS, you have to somehow use a Mac. One approach and one solution to that is we actually have a cloud solution to that problem. We call it the NativeScript Sidekick. Essentially, you can think about it as cloud servers ready to take your requests to compile the application and give you back the compiled iPhone app. So even if you're on a Windows machine, you can use a cloud solution as well to compile for iOS. So the first time it's going to compile it, and of course, building an iPhone app can take a bit, but I think it's pretty much done at this point. But the cool thing about it, and this is one of the attractive things about NativeScript, is that every change that you make from now on doesn't actually require to recompile the application. We set up a process called LiveSync that is just essentially going to send those JavaScript changes into your running app, and then the app just refreshes. So you're not recompiling every change that you make. Now, where's my simulator? Put that right here, next to the code. So we see right here what gets added by that Angular template. It's a very simplistic app with a bunch of, I think these are soccer players. But let's change that. So how about we get a list of the people that are here? So hopefully we all signed up through meetup.com, and Meetup has an API that we can use to get our information. The way that this application is structured, and like I mentioned, we can use Angular. This is very much an Angular application. As we can see, we're using components, we're using services, we're using all the Angular concepts that you could think of. So for instance, we can see that this component is using an item service. So actually, let's modify the item service to reach out to that meetup.com API. And we can take a look. This is meetup.com. I'm using Postman. People use Postman here for interacting with APIs. Cool. All right, so we can see that given the right URL with the correct query strings, we'll get a list of the members that are at a given event and that RSVP to that event. So with that URL, let's modify this a bit. And I have a couple of shortcuts that should help. All right, so we can see now I've created a very simple fetch items method on the item service, and it's essentially going to fetch using HTTP client and provide that to the component. I think I need to make a couple of changes, so bear with me. For instance, this item class currently has this properties, which I don't need. Now we'll have an image of us here. All right, we're probably not compiling. There's probably a couple of errors here, so let's fix that. All right, let's see where we are now. Oh, one thing is that Angular requires that you inject an HTTP module to your application, which is not added out of the box. So let's uncomment that and use that. Take a look at this. And please feel free to ask any questions. Go ahead.
So I assume when you project, it will generate the storyboard and everything on the Ace Code side, right?
Correct. If we take a look at the files, internally what's going on is there's a platforms folder and there's an iOS folder in there because I'm building for iOS right now. And there is a full Xcode project in there. And I believe it is using storyboards and all those concepts. But the actual views themselves, you can think about it as just going to be one big NativeScript view. And then the NativeScript runtime is modifying that one view in the storyboard that would have one story.
Another question is, if you make a change in the Ace Code project itself, would it sync back to the JavaScript code?
I believe so, because the way that the CLI is working is making the changes at the end of the day into that iOS folder. So if you make the changes there, they will be reflected on the app, but they won't be reflected on the actual source code, which is where you should be making your changes. So it's a little bit of a getting in the route of the whole flow, but yes, that would happen. Okay, so where are we right now? We're not in a great place. Let's see what's going on. Ooh, refreshing. Okay, let's stop that for a second. Just in case I did something wrong. Ooh, okay. There's a compiling error right here. Let's fix that as well. Sometimes if you do have errors, you probably want to, not every time, but if you have errors, you probably want to stop it and rerun the run iOS command, which is not going to recompile the application, but it is going to start over the live sync process. Let's see. All right, so we now have pictures of the people that are here. Can anybody recognize their face here? I'll go slowly. These are all people that are RSVP to this event, so what is the percentage of the accuracy of this? All right, so let's do something interesting now. We can see that we now have a master detail. We can see the pictures of the people that, again, RSVP to this event. So let's add a button, first of all, to this. And, ooh, let me clean this up a bit. Here. There we go. That looks nicer. Hopefully I didn't break it. Okay. All right, so let's add a button, like I said. Let's add it at the bottom of the page. Let's do button, button. Text, I don't know, let's process that image. As we can see, we want to determine the mood of that person, which should be here. Come on, man. The age and the gender. And this can be achieved by, like I mentioned before, using the Microsoft Cognitive Services API, the FACE API, as I call it. It can determine a bunch of things by looking at a picture. So let's try and do that. Button. So let's give it a class. Make it look pretty. And I think I need to position it on row 2. Okay. There we go. So now we have a process image button that, of course, doesn't quite do anything yet. So let's do that. So people, are you familiar with Angular or not all that much? Yeah, a lot of you, some of you. Cool. All right. So we can add an event handler to it. There's going to be a tap event handler, and we'll do process image on it. So of course I don't have that process image method, but I can add that right here. And that requires that I have something on my service as well. And this is where we'll make use of the Microsoft Cognitive Services API. And we're calling that method getImageInfo. So the Microsoft Cognitive Services API essentially requires that you first of all get a key that you are all privy to now. This is my key. Please don't use it because I think they do charge you at some point if you use it a lot. But I don't know, I'll figure out a way to delete it after this talk. So yeah, they'll give you a URL. You pass it, potentially you pass it the URL of a picture that you want analyzed, and they'll give you info on that image on the way back. So let's see where we are. So we're going to process the image by calling that service. We're going to subscribe to the result. And then this is going to have a bunch of properties. One of them is going to be the age. The other one is going to be the face attributes. And these are going to be the emotion. What I do with it is I iterate over all of them because most of them will have a 0 value for them. Essentially, they can be, happy, sad, angry, a bunch of different emotions. And there will be a value to each of those emotions. And then I'll pick the largest one of those, and I'll add that to the UI. And what am I missing? Process image is not a function. Well, there we go. So now we can see this guy is estimated to be 30 plus 1 years old. The mood is mood. I guess there's nothing in particular there. And gender is male. That actually should be something different. So let's double check what's going on with the mood. Emotion mood. Try somebody else. Mood. All right, let's just say that they're happy. How about that? So let's try that again. At least we'll get what we get is a value out of it. So that's what they'll give you. They'll give you a from 0 to 1 a value on the actual emotion that they're feeling, and these are happy people. So let's assume that they're happy. I can actually show the endpoint where that goes on, face APIs. So we can see this is the JSON response that we get, and this is what I was referring to before. These are the emotions that we get, and they can be happy, neutral, sadness, etc. You have to pick, you don't have to pick one. It depends on what you want to report on the application, but that's the gist of it. Final thing that we can do to this application is we can make a change on the style. The way that we've set up NativeScript is that we ship it out of the box with a theme similar to Bootstrap. So you can, and we ship it with a bunch of Bootstrap-inspired themes, so you can change the look and feel of the application and, modifying the actual UI. So that's about it for the demo. Thank you so much. Any questions, of course, happy to take them.
Yeah, I have
Please.
two questions. One, what's the difference between this and React Native?
Sure. React Native, of course, is meant to work with the React architecture. The way that we've created is a little bit more agnostic, and we support, on top of NativeScript, Angular, as well as we support Vue. Of course, we could, in theory, support React, but that kind of is pointless because that's, if you want to do React, you probably want to do React Native. So it's very similar. The idea is very similar. When it comes to the actual day-to-day usage, I find that this is much simpler because in React Native, there's less things that come out of the box with it. First of all, you have less, fewer components, fewer things that you can add to the UI out of the box. But of course, there's a lot of plugins for it, and there's a big community around it. So it's very similar, and the philosophy at the end of the day is quite the same. But we feel like we are doing something a lot more open because we're allowing a lot more frameworks, a lot more flexible architectures, and overall, as you can see, I never go into Xcode and I never go into Android, and I do find that to make just a simple plugin for React Native, you probably do have to go down that kind of level. But it's a matter of preference as anything.
So
This question, yeah.
with this, can you have device-specific code?
Very much. At any point, you can do if page.ios and then execute some arbitrary code.
iPad only or whatever.
When it comes to, there's quite a few things that you can do. First of all, you can create platform-specific files. So I can do like myfile.css, or I could do myfile.ios.css. And then the platform on its own picks up that it needs to execute that file because of it's on that platform. But you can also do responsive design in a way for iPad. For instance, you can create a different UI, a different XML file, a different markup per platform. So all those things are possible, including platform-specific JavaScript files if you wanted to. If
you don't use any platform-specific feature, you can use same source code for both.
Absolutely. This I'm only showing on iOS because Android simulators are a little bit heavier on the machine, but everything that I just showed works on Android without any changes whatsoever. And it's going to be just as native on Android. Whenever you see a button, a list view, a side drawer, whatever, that's going to be the real Android button, list view, or whatever.
And if you already have a web application, how much effort you can convert it into?
Well, it depends on how you build that web application. If it's just a 2008 kind of application that you build with a lot of jQuery code, not basically anything is going to be reusable. But if you build that application with, let's say, with the Angular framework or with the Vue framework, everything is going to apply. Absolutely everything. When it comes to the components, when it comes to the services, when it comes to the pipes, if you're using Angular, when it comes to the routing, when it comes to the dependency injection of the application, all that stuff is going to apply. The place where it becomes different is the actual markup. Wherever you had some, diffs and spans and stuff, that's the stuff that you rip apart and you add NativeScript markup to it.
I had a question about the mapping between the APIs and it being cross-platform between iOS and Android. How much of the mapping do you see going down to the method signatures and things of that nature that are more specific to the actual? Absolutely.
So what happens is that the first thing that we did, the first thing that the engineering team did was we don't care what's the same on both platforms. We're just going to map 100% of the APIs, and that's what you see at the very the first thing that you see with NativeScript is that everything is mapped, right? But then we we obviously realized that that's useless if you want to build something cross-platform. That only enables you to write an iOS app with iOS-specific code for iOS, but that's not cross-platform. So what we did after that was we created the wrapper modules, and that's things like making HTTP calls, interacting with the calendar, interacting with the GPS, interacting with the contacts. All those APIs that we know exist in one way or another in both platforms. We created a unifying API so that you don't have to worry about the intricacies of each. And the same, of course, for the UI. We created a markup language that what really happens is that our engine iterates over it. And then depending on the platform, it creates instances of the real UI elements and adds them to the canvas of what the application ends up being.
So like with third-party libraries, it does the same thing, or is it more specific to that library?
Correct. Let's say that I go into CocoaPods and I add some cool library to it. Of course, I'll only be able to use that library and the code of that library in the iOS version of the app. If I attempt to execute that code in the Android version of the app, it's going to crash. And this is why we have seen, and I think I can show maybe a cool sample of that. So this is an open source plugin that we have for NativeScript, and it makes use of two different libraries. One of them is SCL Alert View, and the other one is Color Dialog. This developer realized that these two plugins for these two very different platforms have nothing to do with each other. They're very similar. So he created one unifying API so that internally, when you execute the code for that unifying API, it will be issuing the right alert view. So we can see this fancy alert for iOS, which would also, of course, work for Android. So the way that you write the code is cross-platform. But what's happening underneath the covers is that it's using two different plugins. So, and you can do that with a very thin wrapper layer that, depending on the platform, and in fact, you don't have to code it with all that branching logic, because you can have a plugin.ios.javascript file and then plugin.android.javascript file. So it's going to run the appropriate code, which is then utilizing the library in JavaScript. Cool?
Yeah, thank you.
So what is the JavaScript environment that you're running everything in? Is it like V8?
Yes, depending on the platform, yes, but it would be V8 or JavaScript Core.
Okay. And does it like?
Oh yeah, everybody gets a sock if you ask a question. I'm just going to put the box here. And there's stickers as well.
So like what level of support does it have for various ECMAScript features?
Right. To be honest, I just make use of it and I haven't run into issues. But of course, you can tweak how the engine is running. You can add support if you want, ES6 support and that kind of stuff. Since I wrote this application in TypeScript, TypeScript itself is compiling down to ES5, and that's what the engine is running. But you're free to play around with the engine. It's fully accessible to you. At the end of the day, the app is the source code of the app in Xcode is going to be fully available to you, so you could get very advanced with it. Is there a question around here?
Still got some socks.
All right, so get excited, download it. It's just npm install NativeScript, and then you'll have it on your machine. And then you, as a JavaScript developer, you can build native mobile apps without Cordova. So, thank you.
All right, awesome. Thank you. So, I don't know, Rachel, is there a hard time to get out, or is it kind of?
You've got some time.
Okay, yeah. So if you guys want to hang out for a bit, get to know each other, awkward conversations,
Yeah.
all of that. Talk to some of the speakers, et cetera, et cetera. Well, thanks all for coming, and we'll see you next month.